All right, I think it's recording. Give it a second. I'll start recording in a second.
Sam, do we have a code for this week? I don't see week
So there
6.
should be. Oh, maybe I didn't put the Week06 code. So it's on the GitHub page. I might have only put up the lecture slides on.
Yeah, only lecture slide I see, and in the
Yeah.
code I don't see it.
All right, let me stick the code up right now.
Thank you. That's great.
I was rushing this last night so I could go review that grant.
Yeah. It's really nice of you to do this. Thank you.
Oh, no problem. It's this is something. I mean, first and foremost, this has forced me to finally, this and some other things have forced me to finally learn what I'm teaching you this week, and like learn it from an academic perspective. I've learned the Tidyverse very haphazardly. Okay, so the week06.r file is up on Brightspace if you want to access it that way.
Thank you.
So the Tidyverse, developed by Wickham and colleagues at our studio. I've always felt a little bad for not coming to the Tidyverse earlier. That being said, it was first deployed in 2014, which was the year after I got my PhD, and I was pretty much done learning at that point. I was pretty much going to stop there. I'd learned everything I needed to. They gave me my PhD. I just wanted to stop. So it took me a while to kind of adapt to the Tidyverse because it's a very different approach. It changes how we code to try and make it more readable, which is good because if you look at the code, this code block here, that is not super readable, right? One of the nice things I find about Stata and Sass is that if I were to show Sass code to my brother who's a programmer but doesn't know anything about Sass, or if I were to show him Stata code, he could make a fairly good guess at what is happening, right? It uses a language that reads cleanly, where the dollar signs, the way that you have to embed a variable to write over a variable, there's a lot of stuff in the R structure that isn't as readable. So one of the principles behind the Tidyverse was to make code a little more readable, so you could look at code and kind of understand kind of what it's doing before you understand exactly what it's doing. The other thing is I'll be borrowing heavily from this textbook, the R for Data Science textbook, particularly chapter 5 on data manipulation and chapter 18. I don't pull anything from chapter 18, but chapter 18 really kind of explains why pipes exist, why we use this weird percentage greater than sign percentage operator for doing things. It is also apparently, I didn't realize it, but it has to be where I cribbed the name for this GitHub page for, because it's kind of out there. So the Tidyverse is a set of libraries, and when you load the Tidyverse, you get, let's see if I might have run too much code. It might have disappeared. Yeah, it did. Just 1 second. I just want to show you what happens when you load the Tidyverse, because you can see that it actually loads several data sets. My R still there we go. So everything when you load the Tidyverse, it loads ggplot. ggplot library is ggplot2, not ggplot. I don't know anyone that uses the original anymore, but R is very, very enthusiastic about backwards compatibility. So basically, they had written ggplot stands for grammar of graphics. They had written a library called ggplot, which was one way to approach the grammar of graphics. And then they wanted to completely retool it, but they didn't want to destroy what they'd already done. So ggplot2 is kind of the default now. Tibble, tidyr, reader, per. Dippler is the one we're going to focus on mostly today. Stringer is for better string operators. I don't know what forcats is. I'd have to look that up. So yeah, so Tidyverse itself doesn't have functions. It represents a group of libraries that you can load by yourself. Sometimes I'll only load dplyr or tidyr, but I would say most of the time you just load the Tidyverse, and you're going to need all these libraries at one point or another in your process. So the thing we're focusing on today is the pipe operator. Is this operator, and anyone who's programmed in Unix the pipe is the vertical bar, and this works almost the exact same way as the pipe operator does in Unix, which is to say that it takes the results of a function and passes them as an argument to the first element of the next function. So if I do a table between sex and hypertension, I could also take sex and pipe it into table hypertension. What happens is R in the background takes X piped to table XY and turns it into table XY. So it takes the output of something and pipes it into the first argument of something else. So you can do this multiple times. So you can see that if I were to pipe X into f of Y, I get f of X comma Y. And then if I were to pipe that into G, which is another function, I would get G of f of X of Y, Z, arg1, arg2. So it just passes what this produces. The advantage here is that you do things sequentially and write them sequentially. So the idea is take an argument, run a function on it to produce something new, then take that new thing and pass it to this argument. And things execute in the order you read them. You could always write it this way, but when I write something like this, it doesn't execute in the order I write it. So when I look at this, I have to follow the brackets to the center of the function, figure out what that does, and then work my way out. The nice thing about pipes is that you read left to right. And actually what we tend to do is see my example, we tend to end every line with a pipe. So if you look at some of the sample code here, I should make that bigger. We tend to write it like, where's one with multiples? Here we go. So like dat pipe, and then after a pipe, we tend to put it on a new line just so that we save horizontal space. So the idea is that I take a data set, I do something to it, that produces a new data set, then I do something to that new data set. So you can see what's happening procedurally. Now, the real reason this works is the functions that accompany it in the dplyr library, because what most of them do, all the data manipulation functions in dplyr, they all follow the same basic form, where the first argument is a data frame and the subsequent arguments are what to do with that data frame. So filter, for example, takes a data set and then a list of conditions to keep subjects in that data set. So you can take a data set, pipe it into filter, the data set is the first argument, and then the like sex equals male keeps all the males. So all of them work that same way, where the first argument is a data set and then the subsequent arguments are what to do to that data set. So filter lets you filter specific rows out of your data set. Select lets you pick specific columns, so reduce your data set by only picking specific columns. Mutates used for creating new variables, and summarize and group by, we'll see how this can be used for reporting. And this is where I really find that dplyr and the tidyverse becomes useful. The only other minor difference, I was mentioning this earlier, is that we're now working with tibbles. And this was the picture I was going to include in the slides. I was wondering if anybody got it.
Yes, they're called tribbles.
Yeah,
and everybody loves them.
They're no tribble at all. The worst pun in the history of science fiction. But I didn't, because I didn't have the time. So tibbles are essentially data sets. They work as data sets 99% of the time, but they are data sets. The people that invented the tidyverse, there are a couple things that data sets do, or data.frames do, that specific object, that the people that invented the tidyverse were frustrated by. So they came up with a new data set, because you can't actually change data.frame because there's 20 years of code that depends on it. So one of the nice things about it is that when I print, I don't think I've run anything yet. So when I print a just a regular data frame, it prints as many rows as it can and all of the columns, and it prints a ton of stuff. And the wider your data set is, the more stuff it's going to print. Tibbles have a very restricted print space that's largely the viewing space. So it only prints as many columns as you have in your space. It only prints the first 10 rows. So it makes it, you're not going to, it avoids cramming your console by accident with a bunch of noise. Now it can be a little frustrating, like when you read the CLSA in, for example, or I read a data set in yesterday that has 625 variables or something. So it printed like this, and then it said it only had 30 observations. So with 20 more rows and 575 more variables, and listed the names of all the variables, that list itself can get quite long. So it's not that much more useful, but it is, I do like that because it makes it a little easier that if you want to see if your data read incorrectly, you can just print the data set rather than like restricting it to the first 6 rows and 10 columns. They don't partially match to variable names. So I've shown you in some of the functions, like when we do a regression model, to pull out the coefficients, you have to do $ coefficients. And if you do COEF, it will assume you're talking about coefficients because there's only one variable that starts with COEF. It doesn't do that. That is actually, I find that convenient. It's actually pretty bad programming practice. It leads to mistakes because if I reference something called COEF because there's only one variable called coefficients, if later there's another variable called coefficients too, then it won't know what to reference. So it prevents that bad practice. It doesn't change column names or variable types. So one of the things I'd mentioned before is that sometimes R will turn strings into factors when you read them in. Tibbles won't do that. Strings are always strings. Factors you have to create yourself. It will also take spaces and variable names rather than trying to put periods between the spaces. So if you're using a data frame to prepare output, it's a little easier to try and trick it into having spaces in the variable names. And they also, I say they try not to support row names. They do support row names, but kind of kicking and screaming. Row names aren't something I use very often. You see my rows, so this first column is the row names, are just 1 to 10. If you have meaningful row names, like let's say study ID or something like that, what a row name is, it's essentially a variable that just doesn't follow the same rules as other variables. So I would suggest avoiding using row names as an identifier or a meaningful variable. Actually store it in a variable. So in this case, rand ID is my ID, and I'm keeping it as a variable. I'm not using it as a row name. So you can play around with tibbles. Largely, you won't notice you're using tibbles all that often. They just kind of float in the background. But every once in a while, you'll find some difference between data frames and tibbles. So the first actual function we're going to talk about is filter. So filter lets you subset the data set based on values of other variables. So the full data set, you can see when I print the full data set, tells me it's a tibble with 4,400 rows and 39 columns and gives me the first 10 subjects. And then there are 24 people that didn't get printed. If I run the command filter, and again, all of these Dippler functions operate the same way, where they take the data set as the first argument, then what you want to do. So I'm going to filter the data set on sex equals male. This is the other nice thing about the Tidyverse functions in general. Dippler is what we're talking about today, but the Tidyverse in general is that I don't need to put $ nearly as often as I do. When I say I'm working on a data set, I can then reference the variables in that data set without having to do $sex. So we don't have like if you go back to the top here, we don't have all these $ floating around that just kind of make it a little more difficult to read. So here you can see I can filter it on the males, and now I have a data set of 1944 subjects. You can see all of them are male. Well, the first 10 are male. Take my word for it. The rest are male as well. Now I could have written that rather than filter dat, and rather than dat as the first argument, I could have done dat piped to filter sex equals female. So this is the equivalent of this. I mean, not the equivalent because they're filtering on different sexes, but these are two different ways to execute the same command. And my filters can be, I can, if I separate my filters by commas, I can have multiple filtering options. So if I just want obese males, I can filter it on sex equals male and then BMI groups equals obese, and that gives me a much smaller data set. And then if I want to do an OR, I can just use this single vertical operator gives me an OR. So if I want everyone that's overweight or obese, all the BMIs over 25, I could do BMI groups equals obese or BMI groups equals overweight. I guess I could have done BMI greater than 25 as well, but I wanted to show the OR operator. So filters really, you'll find yourself using filter a lot because it lets you subset your data really quickly. The one note, and this seems intuitive to me, but the filter only shows the row where conditions are true, and Boolean tests like the two equal signs or the not equal sign, they often act weird in R. So just know that if there's a missing value here, that's the same as false. So when I say sex equals male, that gives me all the males, so all the females and all the people with missing sexes wouldn't be included. That seems intuitive to me, like if I wouldn't want, but just you know that when you're filtering, you lose the missing values as well.
Sam, what do these things exist as once you filter them? So like looking at the non-piped code, we write something like dat $sex is equal to this thing, and it's kind of I know how to call just the thing I made. How would you do this and then refer to your filtered data set of only sex and obese
so that,
later?
I debated whether to include that. So this is creating a new data set. If you want to if I wanted to save that, which I should, because you shouldn't be creating data sets without saving them, you could say dat
simple as that, just that equal sign
over
okay.
equals.
All right,
So you're just this is creating an object, so I just need to assign it to something. But you're right, like it's these three commands are all essentially useless practically for our programming, because I would never create a data set without doing something with it.
And it's smart enough to know, like so for example, just the obese men, you only have to put dat.obese equals at the very beginning, and then it says filter sex, there's another line. You can just keep going.
Yes,
It's just,
so
okay, thank you.
When we have these complex, like multi-pipe functions, it's as if they're a single line. So we've got, there's a big one at the bottom, right? Like the last one we do, this one. This is 1, 2, 3, 4, 5, 6, 7, 8 pipes. That's pretty good. One of Hadley's pieces of advice is don't use more than 10 pipes. If you're using more than 10, split it, because you could split these at any point, right? Like I could, rather than doing, at any point I could assign it to an object and then pass that object to the next one. I could stop at any point. His point about multiple pipes is that if I run this and it breaks, I don't know what caused it. One of the commands caused it, and the error codes will be a little bit helpful, but the more pipes you have, the harder it is to debug. But we'll get to that one a little later. But yeah, so these commands, all of these commands produce an object. It's almost always another tibble. So you tend to be assigning that. So it often, if you're doing this as your data cleaning, it would be dat equals, and then because you want to change your original data set. So filter works on rows, select works on columns. You can see as a simple example, I pass dat, and then I just list the variables I want to select. So you can pick individual variables. This is useful if you want to reduce your data set. For example, if you're working with a data set with 625 observations, 625 variables, maybe you want to reduce it to a set that you're interested in. Most of the time, you'll just list individual variables you want. There are some ways to pick, like, all the variables that start with a character, all the variables that end with a character. You can do some string matching on variable names with contains and matches. You can also do, I believe you can do, I shouldn't say this without checking it. I think you can do dat select dat 6 to So if you do, in Stata, how you can do like one variable dash another variable, and it would pick all the variables in between. You can do the same thing with select, only it's just a colon rather than a dash. So that's a way to select. If you know there's a range of variables, you can select them with that rather than typing them all out. I didn't get too deep into select because it's fairly straightforward unless you have like string matching to do on your variable names, and then it's incredibly complex. So there's no real middle ground there, but we tend to use it just to reduce the data set to a smaller set. This is often helpful when we're doing pre-cleaning for graphs or tables. The other big command we use is mutate. So mutate is the command to create new variables. So again, the idea is your first argument's a data set, and then after that is equations that would create a new variable. So we can see that here I'm turning the death variable into a factor variable because it's coded as 0, 1, and I'm reassigning it to a variable called death. Here I'm taking the BMI variable. This is the same as we have up at the top. I'm taking the BMI variable and cutting it into 4 groups. And here I'm doing a check on that variable that's right, to see if who has a normal BMI. And then what's produced is that we can see it's my regular data set. The first thing I did was reduce it to the 4 variables I'm interested in. So these are those 4. And then these are the 2 new variables I created. So you can some of the details, you can overwrite a variable. So if you're turning a variable into a factor variable, you would often do like death equals factor version of death. I don't need to save a new copy. Here I'm creating a new variable from the BMI variable. And what's interesting is once I create this variable at the second command, I can use it in the third command. So I can create a variable, then use it within the same function because the library executes them sequentially. So I created a BMI groups, and then I checked the BMI groups I had just created. Yeah, and these can get fairly complex. The math can be as complex as you want. This is often, so you can see, if we go way back to the top, here. So here I'm creating 4 variables. You could do these all as different commands within a mutate function. So I've actually showed you how to do the BMI groups one and a different version of the sex one, but you could have done sex, diabetes, and hypertension within a mutate command. I would caution against doing this is one area where, like, when I'm doing this initial variable cleaning, this is a place that I often continue to use. I don't use mutate all that often for my initial data cleaning. I tend to keep it in this kind of structure, doing each variable by itself, just because it's easier to debug that way. If doing all your variable conversions in a single command, if any of them break, the entire function breaks, and then it's hard to figure out I do find the errors in the Tidyverse to be a little more informative than the errors in regular R, although that's not entirely true. I had an error come up in our breakout activity that I had a hard time debugging. But I would rather write that $sign a bunch of times than risk having a complex debugging problem in the future. So I like doing it variable by variable because, for example, if next time I load this, if the next data update, hypertension now has 3 levels, I want to be able to catch it at that point rather than have it be part of a function that breaks. So the final one I want to show you, and this is more about showing you how we kind of build piped functions. So the idea here with summarize, I'll take it into this one. So summarize reduces the data set to a single variable, or maybe a set of variables. So if I run this, I get the average age. And if I want to do multiple variables, I can get the average, I can get the standard deviation, I can get n, I could add, median equals median. True. So if I do that, I can get 4 of them. Now, one of the so let's say I do this, but I know there's some missing BMIs. I think if I do 19, is it? Yeah. There are 19 missing values, and my n function is wrong, right? It shouldn't be 4434 because I don't have 4434 BMIs. I have 4434 minus 19, so 4425. The thing is that the n variable just gives you the length of the object it's operating on. It doesn't deal with missing values. So what I'm going to do is I take this, and before I run the summarize, I'm going to filter on not is.na BMI. So if you go back to the filter command, what the filter command does is it allows us to remove rows. So I want to, sorry, it allows us to keep rows. So I want to keep all the rows that are not missing in that variable. So I want to keep all the observations that have a BMI. And the nice thing about this is that now I could actually probably drop these. I don't need to tell it what to do with the, and there's no reason to do this, it doesn't hurt to have them, but I don't need to tell it what to do with the missing values because I've filtered them all out now. So now you see we get a, I shouldn't point, you guys can't see what I'm pointing at. We get a 4415 here instead of a 4434. Now where this really becomes valuable is the group by function. So if I do group by sex, what that's going to do is it's going to, I do it before the summarize, and now it's going to summarize over each of my groups. So you see I get a different value for males and females. And I can group by multiple values if I want. So if I group by sex and smoking, I get the values for sex and smoking. But now I see that my smoking value variable isn't formatted. So I can format it. Smoke equals factor 1. And pipe that in. And I now I'm going to format it, then group it, then summarize it. And now I get a slightly nicer table. And now, because I want something that looks nice, I'm going to go back to cable. So I had showed you if I do cable, that just puts it in HTML. But if I pipe it to cable styling, that prints it to my output area. I was saying before that we tend to put every pipe tends to be a new line. This is an example of a command that I almost always put the two together. I never run cable without cable styling because I just always, if I have a function to make tables pretty, I'm going to make tables pretty. So from there, I'm going to do a little bit more kind of, so I want to do row spec on row 0 equals, or what is it? Background equals cyan. This is a violation of one of this is a violation of one of the Tidyverse's core principles, is that it's developed in New Zealand, and all the core Tidyverse functions, if they take the command color, they also have to take the command color with a U. So you can tell that cable styling is written by someone not from the Tidyverse and probably someone from America, because they didn't implement that. I didn't think they did. I just wanted to check. So now you can make a super
beautiful
great colors there. Yeah, and then you can keep, so you can see how, like, we started with this. I guess we didn't start with that one. We should have done it in BMI, and just we iterated to get a more and more complex report. I can't remember what the last one is, so I'm going to cheat and go back down to the bottom. I can't remember how I got the striped cable paper. Yeah. So how that turns into this by adding commands at different steps to make things more complex. That's also how you can end up with pipes that are, you can end up with 10, 11, 12 pipes in a command, because it starts with a simple thing and you just keep making it more and more complicated. Go ahead, Dan.
So you grouped by sex and smoking status before summarizing.
Yes.
So
Yeah.
it's sort of like you're setting up like what you want the table to look like, then you populate the contents of the table. If you flip those, if you say I want to summarize, like so in Stata, what you'll do is you'll say I want to summarize something, and then you'll put all the qualifiers underneath. Does flipping makes no sense in this setting because the pipes have to happen in a specific order?
So for the Stata programmers here, it's like the by variable colon option for grouping rather than the sum. It's the by before the colon, not the by after the comma.
Okay.
And that much like Stata, not every function is going to implement this. Like some will do it the other way. The way you can visualize what you're doing is you take your data set and you're basically splitting it out into 4 data sets.
Yeah.
Then you're running a command on each one. So I can actually, I believe we can even get, no, we can't. So you could, after group by, if we do this, we could then run, there are commands to run a regression on each of those individual data sets. So I could do like a stratified regression on each one. I just can't remember what the command is there. If you look at the pipes chapter 18, there are different kind of pipes. There's a, rather than there's one that has a T in it and one that has a $sign in it that are used for piping to other functions. I've never used them. I actually learned about them last night when I was preparing for this lecture. But there are ways to, because when we stop here, it doesn't look like this, but this is essentially created 4 stratified data sets, and then each one you would operate on.
Okay. So I guess the tidyverse, the tidiness is simply appearance, and this is exactly how you write it in a non-tidy setting as well. You'd follow this order.
Yeah, so
okay.
we could rewrite this all, if we were to try to rewrite this as a single command in R with brackets, it would be an abomination. Because the outside, it would have to start with row spec, right? We would take row spec, we would pipe this into the first argument, then pipe this into the first argument of this. We would never do that. But even the advantage with this is that if so let's make this a little bigger. So each one, we can, when I come to this later, I can look at it and see what's happening. Okay, I take a data set, I drop the missing BMIs, I convert one variable to a factor, I group it by sex and cur smoke, I summarize amongst those groups, and then, oh, this is just printing. The cable stuff I find doesn't read quite as cleanly. The advantage is that let's see if I can find a super complicated one. I complained to my brother that because it's so readable, you don't get to create like super duper ugly stuff.
What's the point of being an academic if you can't produce something?
Yeah, if you can't, well, this is
unimpenetrable.
Every once in a while, you'll find yourself writing like nested commands, because it's you go through the same process where you're like, oh, I need to convert it to a factor first, or oh, I need to do that, and you do functions within functions within functions. But the inside out nature of base R makes that command a lot uglier than the top down nature of the tidyverse. But you can get some. Who's I doing that for? I'll figure it out later. I want to go to the breakout groups.
No, that's cool. Thank you. I just wanted to sort of connect back to what this is trying to solve. Okay, thanks.
The major advantage is that I don't think I was doing it. No, there's none there. The major advantage is that it reads top to bottom or left to right if you're not using character turns, and that makes it a lot easier to kind of follow along. And then if we look at this and we realize, oh, I need to drop the people that are underweight, I could easily add an additional filter that is BMI greater than 18.5. I find that's the other advantage, is I find it a little easier to modify, because you can add, like if you realize your data set isn't subset the right way, you can see exactly where you're supposed to add it. The big problem is that there are functions to do everything, but you don't know them. So you'll find yourself, the best way to Google this is dplyr, how do I, and then your question. and you'll find an answer on Stack Exchange that will answer your question. Some of them get super complicated. Others, it's often because you didn't know there was a command that does exactly what you need to do. So let's go to the breakout sessions now, because I want to give you some time on them. We're going to go back to what we did in week 2. So this was the code we used in week 2, where we have subjects and measures, and we joined them all into a single data set, and then we used melt to turn them into a long data set. I don't know if we actually got to this part of it. But I want you to take that and try and redo this with pipes. So a couple of hints. The data creating the combined data set needs at least 2 commands. You can't do it as a single command. One of the things about one of the challenges with the Tidyverse is that it needs to operate on a single object. So like you have to clean the first data set, clean the second data set, and then join them. You can't clean both data sets in a single set of pipes because it starts with like dat piped into something. So it needs at least 2 commands. My suggestion would be to format data 1, then format data 2, then join them. For joining them, merge, left join, and or right join would work. I can't remember which one works best, but all of them can work. Those are the 3 commands. I think merge is what we talked about in week 2. We have some nested commands here, so you can see here we ran 2 upper on sex and then turned it into a factor. Nested commands don't work well in Stata. You have to figure out a way to break them out. And finally, if you get to the turning it into a long data set, there's a command called pivot longer in Dippler that should be useful. So take a look at that. How many of us are there? Oh shoot, I need to recreate the rooms. So pivot longer is the command that would be most helpful. So I'm going to send you guys out to your rooms, and I'll come join you shortly.
see what I look like as a Disney character. Oh my gosh! Wait, what? Oh, I look cross-eyed there. Wow! Look how it's tracking my facial expression.
We're back. Okay.
All right. So it seemed like everyone made. Oh, where's it? There you are. Everyone made decent progress on the first part, and we're going to take 10 minutes to solve the second part together. I've cheated a bit. I do know how it works. Because the second one is a good example of kind of doing Tidyverse activities in parts. But let's start by talking about the first one. All right, so sorry, my windows are flying all over the place. There we go. One thing that I find useful sometimes, Control Shift F10 restarts your R session, so deletes everything you have and starts from scratch. I do that fairly often with my teaching stuff just to make sure that the script I'm writing works from scratch. I'm going to start this one from scratch. And then the other thing is do I clear the console? Sorry, 1 second. Our studio's, I found recently our studio's been a little laggy.
I think you do Control L to clear the console.
Is it L? Thank you.
Yeah.
So that's something I've been finding recently is that if my R gets a little laggy, pressing Control L deletes everything you've printed so far. And that has solved it on occasion. I don't know enough other than that to actually tell you what is causing the problem, or if that's the problem. That it might be a placebo. But so load the Tidyverse and my 2 data sets. Okay. So the a lot of you did like clean the first data set, clean the second data set, then merge them. So 3 separate steps. That's a fine way to do it. Probably the best way to do it. I did it in 2 steps. So I did the merge as part of my second data set. So for my first data set, it's just a mutate, converting, and roll. The one thing you could do here if you wanted to split it into 3 commands is sex equals to upper sex. So convert sex to uppercase, convert the lowercase to uppercase in 1 command, and then convert it to a factor. Last night, this was the only way I could get it to run, but I think I just had an error in my code somewhere. So it runs fine now. So then we look at D1. It looks okay. Piping it to a tibble there just makes it a tibble, so it's a little nicer to look at. For the second one, same thing. A number of you, when you run this command, well, not a number of you, every one of you, notice that you got this warning message. And I mentioned this once before, but it's worth talking about again. Warnings aren't errors. An error means something didn't work. A warning means something weird happened. So sometimes when you're, a good example is when you're fitting a logistic regression in R, if you have either small sample sizes or big predictors or boundary issues, you might get a warning saying either it's like probabilities greater than 1 occurred, or you'll get errors about prediction. And what that means, like errors about non-convergence, they're not errors because the model's still finished. They're warnings because the model might not be right. So there's a difference between warnings, which is what you did worked, but something you might want to know about happened, and errors, which are it broke. So in this case, we get a warning because in converting blood pressure to numeric, we turn 2 values to missing, because if we look at this one, whoever was doing the recording wrote no reading a couple times rather than actually either leaving it blank or writing NA. So this is recorded as a character. When we convert it to numeric, these values get converted to missing, but R just lets you know that when you did this, some values that weren't missing before are missing now. So then I could have taken all this, assigned it to an object, and then joined them. I decided to pipe this to this function and do it as a right join. So this is the same as right joining D2 on D1. And then I did a range. A range just sorts a data set. So if I do this, we can see that it worked fine. It has the identifying variables at the end rather than the beginning. That doesn't matter that much. People might get a little confused by it, but the order of the columns really matters. If you do a range, it's going to sort the data set by this value. So I'll run that again. We can see now it's sorted 1 to 10. I only did that because the example code I gave you had it sorted in this order. So if you wanted to compare the sample code to this code, it's easier if they're in the same order. So that works pretty well. So we can, then the next question is how to pivot it longer. So in the previous example, we made a long data set out of the blood pressures, a long data set out of the dates, and then we merged them together. What we're going to do now is a similar thing. So I'm going to create a data set called bp.long, and I'm going to pipe, oh, nope, sorry, it equals d.all. So we're going to transform d.all into a long data set. And I think I will eventually assign that, but for now I just want to leave it blank so it prints every time so I can see what's happening. So what I want to do is I want, if I look at pivot longer, and you can look at the help file for this. Pivot longer. The other thing you can do that I tend to do most often is Dippler pivot longer. You'll find lots of places on the web have the help files uploaded to their website. So I often tend to browse it here rather than in the R help file because I can zoom in here, and as I get older, these become harder and harder to read. So you can see these are all the columns, all the arguments that it takes. Data obviously is the first argument, it always is, and calls is the column that we're most interested in. So it shows what columns am I going to pivot into the longer format. So what columns am I going to repeat multiple times? So what I'm going to do is I want to keep sex, age, and enroll date. Sex, age, enroll date. Does that have to be in quotes? No.
I think those are the ones that you have to that it pivots on.
Oh, okay. Oh, right. Sorry, I did that the wrong way. You specify. You don't specify sex, age, and enroll date. You specify all the other ones.
Yeah.
So you could either like
I did this
BP01, cis BP02, cis BP3, cis BP04, like that. Yeah. Now, one problem is that it so it kept the ID, but it also kept all the sample dates, and I don't want those. I just want the blood pressures. So there are two options. I could either drop them from here, or I could drop them afterwards, and I'm going to choose to drop them before. So before I do pivot longer, I want to select minus date 01, sample date 02, sample date 03, sample date 04. So if I just run this command, we can see what it does is it just drops the date. So now I just have the IDs, the blood pressures, the sex, and the age. And then I'm going to pivot longer to get the sex, the age, the enrollment date, and then the variable and the value. And Kent is going to explain to us how to change name and value. What are those arguments, Kent? So Kent showed me how to do this in his group. I didn't realize there were name.
Yeah, names _2 for like the
Yeah.
index or whatever, and then values 2.
Okay, so names 2, I'm going to make it index. Values 2, I'm going to make it. These are blood pressures, right?
Yeah.
Yeah, there we go. So that looks pretty good. I've got the ID, the sex, the age, and the enroll date, and then the 4 blood pressures for everybody. And I could now, if I want to get rid of, I could filter not is.na on BP. So I could drop the missing blood pressures now. I don't have to, but I'm actually going to do that later. So that works. So that works for my first one. So I'm going to call that bp.long. And now I want to do the same thing for the dates. So the difference is that instead of sample dates, I want blood pressures here. And I'm going to show you a helper command. So rather than listing them all out, this is where some of those support commands for select can be helpful. So I want to, oh man, I thought I was being so clever. What's wrong with that? Oh, spelling is important. The word with doesn't have a D in it. So if you do a select starts with, we'll pick all all column names that start with a specific character. So I want all the blood pressures, and then the minus says to drop them rather than keep them. So I drop all the blood pressures, and then the columns I'm going to. I did figure out how to do. Oh goodness, what I do there. Pivot longer take starts with as well. So I can do the same thing here. Well, I can do starts with sample date. And then the value instead of BP is going to be sample date. So now I've got the ID, the sex, the age, the enroll date, the index, and the sample date. So I've got the repeated values I want, and then for each of their dates, I've got what date the sample is actually taken. So I'll make that date.long. So now I have the BP and the dates. What would be my next step? Yeah, I just want to merge them together, right? So if I do merge using pipes, so BP long into merge on date.long. Let's try that. I might not have actually run this command. Huh. Wonder why that didn't work. Let's try left join. Oh, I see what it's doing. Okay, I see what I did. So that was right that it's not working because my index variables aren't the same, right? So if you don't tell merge what to merge on, it will merge on all variables that match. So when it tries to match this data set to this data set, it finds all the subjects, it finds all the variables in common between the two data sets and matches them. And the problem is that my index here is blood pressure 01 and my index here is date 01. So because they don't match, they're not actually merging. So I need to change these two variables. My index can't be called sysbp01. It just needs to be 01, right? Because it's not I need to be able to match this value to know to merge these two. So I need to convert sys BPO1 to just BPO1. So I'm going to go back to my long data set and I'm going to mutate. I'm going to change that variable. So I'm going to say index equals use gsub. Make sure that worked before. Yeah. So gsub does regular expression matching, but right now what I'm doing is I take this value and I replace all occurrences of this with this. So in this case, I took my original index and replaced all instances of sysbp with nothing. So now it just says 01. And I'll do the same thing down here. Simple date. Index. And now if I merge them, they now match on the oh no, you could do it without open close bracket. So now you can see that it's merging them correctly. So we see that and finally I guess now I can drop the missing values because they're starting to fill things up a bit. Filter not is.nab. So now I've got for my first subject, I have female, all the sex, age, and enroll data are all the same. This female made visits 1, 3, and 4, and these were their blood pressures and their sample dates for each one. So next week we'll learn how to take this data and start plotting with it, because this long data structure is essential for a lot of different ggplot functions. So when we talk about ggplot, we can now pipe this to if we do something like I'll do it long to ggplot x equals date p color ID. Didn't do anything, but if I add geom line, maybe that is right. Maybe it's just maybe I want to do x on index. No, well, I'll figure out how to get it to work. As you can see, ggplot's a little tricky. I'll keep playing that with that here for a bit, but if anyone has any questions, feel free to ask them. Otherwise, you guys can sign off. And next week we'll learn how to get this to work.
Yeah. Thanks, Dan.
Thanks,
I have
Dan.
one question.
Yep.
For the legend, is there a way to like manually override, like if you wanted to make those dots or like plus
In
sign?
ggplot?
Yeah, yeah.
Yes, yeah. So there are a lot of both precise and structured. So if you use different themes, that'll change how it's presented. One of the problems is that I want my ID to be a factor variable.
Yeah, and it's just continuous.
Huh.
Oh.
Yeah, so you can see there
Oh,
you got the legend, but none of the lines plotted.
Oh, so for the legend there could you change those lines to dots or something like that?
You could, not with geom.line, because I'm not drawing lines. If I wanted to draw, if I did geom.points.
Oh, I know.
Oh.
It would just automatically do it. Okay. Yeah, I have on one of my plots, I have a bunch of horizontal lines, and then I put a vertical line with whatever vertical, what it's called, and then it changed all the legends so they all have like horizontal and vertical lines.
Oh
Like,
yeah, there are ways to suppress. I think like if you look in the because for this example, I don't really think I want a legend. There are ways to tell it to suppress the legend. Yeah, show.legend. So if I do
okay.
show.legend, my goodness, GEND equals false.
Then that would.
It just does the lines.
Oh, okay. Yeah. Yeah. Nice. Yeah. So if I do that in my vertical line, that might.
I don't want the lines that way. I want them the other way.
Ken, you should pull up your specific figure generating code and just say.
Yeah, I can take a look at it. As you can see, I might not know the answer, but I can.
Yeah. I have
can
it
help.
on the computer. Okay.
I could help you.
Figure out the thing. I think what you said there, I think the show.legend is the problem because I couldn't figure out why. Yeah, I think I had like this manual override thing going on in it, and it seemed like it was a bit, no, it didn't always work. Yeah, the way I wanted to. Maybe it was working.
There we go. And also this graph is useless. That was also one problem I was having because this is a fabricated data set. And I forgot that you need to both. So coloring something makes it look like it's grouped, but it's not. That's just the color. So when I was doing this without the group, it will color the line segments based on the ID. In this case, it won't, but it's not. It doesn't actually think they're separate subjects. If you had the group that, but likewise, if I remove color, it will still group them, but not color the differences. This is what the individuals look like.
Yeah, I thought the color would automatically do that.
Color, no, and that's the problem is that color, it adds colors that make it look like they're grouped, but ggplot doesn't actually know that they're individual groups. So then when you tell it to draw a line, it doesn't know what points it's drawing the lines between. Like it doesn't know where to start and stop them because there were no groups.
Yeah.
If I do violin.
Wow.
Oh, I think I tried to do too many of them.
Oh yeah.
I find ggplot more than anything. I have to Google how do I do this.
Yeah.
And then once I see how someone else explained, that's still not working. You can see a violin plot there. So what I'm trying to do is d.long.
Yeah, you can't. It's more difficult to figure out intuitively, but then when you see someone else do it,
and then once someone, yes, I did. I like this error. When you switch to ggplot functions, use pluses rather than pipes, because pipes are passing things from one to the other. ggplot is like, do this thing, then add this component. So it's a different grammar. But people make this mistake so often that they detect it and tell you specifically that you probably wrote it the wrong way. There, that's what I was trying to do.
Yeah, cool.
Oh no, that won't work because color's not part of the. Yeah, there we go.
Yeah.
This is what we're starting to get to the point where you realize that this fake data set I made up is pretty useless for any kind of statistical analysis because I think they're all just I think all the blood pressures are completely random.
Oh,
Yeah.
those are some nice vases.
Yeah, they are. But like the thing is that once you start getting in, like we could kind of get away with some of this linkage and stuff, but once you start doing summary statistics on it, there's nothing there. Where
Yeah.
like the sex and gender stratification of BMI, for example, in the Framingham data set, you see these little patterns that convince yourself that if you do the same thing for our blood pressure example, it's just not interesting because they're all going to have essentially the same blood pressure because their blood pressures aren't related to like sex, age are created completely randomly, and then the 4 blood pressures are created randomly unrelated to the sex and the age. So there are no patterns in this data we just worked on. Because I didn't think it was worth trying to build patterns into it because we weren't going to go that far.
Can I ask a question about just the pivot longer?
Yeah.
I'm getting this error saying pivot longer applied to a character seems to be a problem, but I'm not sure what the character is. Like I've tried to capture exactly what you wrote there, Sam. The line I'm at is BP long equals
This
D
one?
all. Yeah.
So this is one of those places where oh shoot. So you saw one of the first things I did when I was debugging it was I deleted the assignment part and just ran it as
Okay.
so I do it pipe by pipe, and this is where if Tidyverse has one shortcoming, it's in the debugging because it's hard when you run a command that you thought worked and it didn't work and it's got 9 pipes in it. It's not the easiest to figure out where it broke. So you can kind of, why don't you share your screen with me and I can look at it directly.
Yeah, sure. I do like how you have the errors, the missing values in red. Mine does not. The scheme I've picked doesn't do that. Hold on.
Oh yeah, I think I mean your colors. I'm gonna sit down. Your color scheme is always going to be. Dan, you like that stupid gamer chair you bought, right? It's comfortable.
Yeah, I spent lots of money on chairs all at the same time, and it's the best one that I bought. It's from Costco.
Yeah, I saw it in Costco and I thought, hey, Dan's chair.
Buy it. It's the best value. Like if you buy other chairs that try to be like this chair, they're like $400.
Yeah, and I noticed yesterday that I'm getting lower back pain from this cheap IKEA chair, and I don't fault IKEA. I bought a $40 chair from IKEA thinking I would use it like an hour or two at a time, a couple nights a week, like it was my home office chair and not my 8 hours, 10 hours a day chair.
Times change.
Yeah.
You gotta get game. You gotta get that gaming chair. So here's what we do. Here's what we get. I can run all of this up to here, and it'll work. Right. As soon as I say, please pivot longer on these things, it tells me error in used method pivot longer. No applicable method for pivot longer applied to an object of class character. So I don't know if it thinks one of these are characters. Is that what it thinks?
This is though. When R throws a completely nonsensical error, it's almost always because of a typo, and in this case, your pipe after select is wrong.
Oh my god.
Yeah.
This is one of the things that's frustrating. R is not unique this way. Programming errors tend to make sense when you're close to the right answer, but that makes them really confused about the commands because %/% is actually the command. I think that's the remainder command. Like if you run 7%/%2,
Like
it gives
yeah.
you 3, because if you divide 7 by if you divide 7 by 2, 3 is what's left. Or no.
I guess you could stop the recording
Oh yeah, good idea.
now. Now we've talked about gamer chairs.
Yeah.
Go to Costco.